My name's Alistair Grant. I work for feenk with Doro and Gt Pharo here, and today I'm going to be talking about working with remote images. So the things we're going to be covering, green threads, just in case there's some people here. Very quickly we'll go through what that means, why we want to work with remote images, a little bit about the architecture, and really about what are some of the design decisions that for us were more impactful. A couple of open issues, features, and some demos. So just in case you're new to Pharo and Smalltalk, if you're familiar, most operating systems, you have lots of processes. A process can then have lots of threads, and those threads, if you've got multiple cores, they can all actually be executing at the same time. We have what we call a process inside Smalltalk, but that's only running on a single operating system thread. So even though I might have 10 processes there that are all trying to do calculations at the same time, in fact, the Smalltalk VM is serializing them and saying, I'm going to do one at a time. So that means, obviously, there's a limitation there that I've got my nice laptop, it's got 9 cores in it, and they're all 8 of them are sitting there idle, and one of them's actually doing some work at any one time for my process. So obviously, we'd like to be able to take advantage of all of those extra cores. So the sort of things that we're going to be using this for, testing is the big one. So if we've got a large number of tests, that might take 20 minutes to run a subset, which I would like to get through in a couple of minutes to speed up my iteration. If we're running the entire test suite, it might take up to 24 hours if I was just going to run that on one laptop with one image. So the more workers I can get, I can compact that right down to maybe 5 minutes. We also want to be able to do it for different systems. So in GT, we use what we call examples. They'll get run through as tests. So we're not really interested in the result in that case. We just want to know that it's completed successfully. Pharo, of course, has S-unit tests, and maybe there's a proprietary or a custom test framework that we also want to be able to run tests in. If we're doing code analysis with something like Moose, that can be very large. If I can push that off to a separate image, have it running in the background, loading, whatever it's doing, and be able to continue, and then inspect all of that model as though it's pretty much the same as if it was in my image. That's useful. Code searching and anything else you want to do. So this is basically the architecture of how it works. We have the idea of a job. A job has a whole lot of tasks associated with it. You submit that into the remote runner, which is basically the manager for this, and it then hands the tasks out to workers. So the unit of work that actually goes from the job down to the worker as an individual task. So we're going to want to structure those tasks to be able to spread them across multiple workers. I've got the dotted line there. You can see, hopefully, around here is indicating that initially this is in one process. So the job and the remote run are all a single process on the laptop, and the workers are then separate images that are running either on one machine or could be spread out over the network. They can be running in the cloud, however you decide. Okay, so let's take a look at what we need to do to get one of these running. So first thing I do is create a task. And in this case, we're just saying we want to run all of the examples inside one class. I've just got a little simple test class here. And so when I first create the task, of course, it's not started. It's got an ID and no real attributes because it hasn't been run yet. So I'll assign that to a job. And same thing, job obviously hasn't been started yet. There's nothing there. And we can inspect the remote runner here. So this is saying that it's idle. It's not doing any work at the moment. There's 3 registered workers. So I started up 3 processes. And they're all available because it's not doing anything. So if now I get to the point where I actually say I want to run that job, then my job's going to change that state to started. It's still just got one task. And now we can see that the runner's busy. It's got one job and it's finished. And before it was showing that it was executing. So now I can have a look at that and see that it's completed. We've got one result. There were no errors, and I've got some basic statistics about how long it took. And if I want to, I can go and have a look at the results. So this particular set of results is about the task. It's just saying that that task actually returned an array of 4 things, and they happen to be the results of those 4 tests. So we'll just leave that for now and come back and have a look at it a little bit later when we talk about how we actually integrate this. Obviously, I don't want to be writing code all the time, every time I want to do something. So if we had a look at the job, at the moment, really, we only have 2 job types. So in this case, I used the task job there. I just gave it the task that I wanted it to execute, and it went and ran it. One of the things we can do with this is code synchronization. So I've got my development image here, and I've got those 3 worker images. But if I'm making changes to the system, I don't want to have to go restart them every time or reload them or whatever. So we have this code sync job, and it basically then just listens to Eposia, and whenever I make a change, it creates it submits a job with those changes, sends it down to each of the workers, and now my worker has the same code as the development image. And same thing for the tasks. So you can see here, we've got different types of tasks. We've got up the top, there's an abstract test task, but I want to then run tests as examples or as SUnit tests, or in third case, it's a proprietary test framework. So they're able to take account of the different things that I actually want to do on each worker. You can also see there's a code sync task, and then the last 3 we're not actually using all that much at the moment. Well, script task, if you just want to do general processing, I can send down a bit of a small talk code and just get that run on the remote worker in parallel. Okay, so just to take a little bit of a different view on how it's put together, the remote runner is really just providing services to the application, and it sits on top of Pharo, which provides remote execution to one machine. And so Pharo basically just allows us to run a script on another machine. So we take the task object, serialize it, use Pharo to send it down to the worker, tell it to execute itself, get the result, and bring it back. The other thing we can do then is it's got proxy capabilities. So if I want to inspect that object, if it's something like a moose model, I can have a proxy to that moose model, and I'm going to be able to see everything that's been done in that worker. And then that just sits on top of sockets. So just to go through a few of the design decisions, the basic idea of jobs and tasks and a manager and workers is pretty simple. But what have we done that particularly stands out? So in this case, the workers are responsible for establishing the connection back to the remote runner. So the reason why we do that is because there's lots of different ways that we might want to start it up. So in this case, I've got the workers here. I actually want the runner to start the workers for me. I'm not interested in manually looking after them. So whenever I start up the machine, start up the image, it just says create 3 workers and have them sitting there. For our CI system, basically it's just sitting there the whole time. A new image comes along, it starts up, and the CI will take care of deciding where the workers are going to run. If in a larger test system such as Liveware's got, if I'm running it up in the cloud, then I'm going to want to manage creating the image that I want to test, starting up the runner. It'll then start up a cluster or an auto-scaling group of all of the workers. So that might be 30 or 40 workers. You've got 20 cores each, and you end up with 1,000 images, which now will connect back to the runner, and it'll hand out all of the work. And then when the testing's finished, it'll shut it all down. So the way we do that is by, sorry, I'll take one step back. Those tasks, when I'm doing the testing, I might want to run the same test on different platforms. So Windows, Linux, Mac M1, Mac 386. So what we can do then is when a worker connects, it gives some attributes about what it is. It gives its ID, the platform it's running on, and anything else that you decide you want to put in there. So then when we're submitting the tasks, the remote runner will look at the queue of tasks, and a worker says, give me the next task. It'll go through that queue and say, find one that has matching attributes and make sure it only runs on the appropriate worker. So for the manager startup and shutdown, I mentioned before on my laptop, I want it to start up the workers automatically, but if it's on a cluster, we want to manage it externally by the job. So in this case, you can see up the top here, we've just got an abstract manager class for the local one that's going to automatically start the workers. And then for this one, that says also enable code sync. So that's the development scenario where I've got my development image and I want to make sure all of the workers always have exactly the same code. And if it's going to be managed externally somehow, I'll just say leave it manual. Don't worry about starting any of the workers, that'll be handled separately. So and the same thing for the job. It just says when it's starting a new job that it should submit the job should submit the tasks and we'll mark it as started. But then we can go through and do other things. And so for this example with the Lifeware one, it's at this point that we then go through and say, start up all of the auto-scaling group. And once those machines start up, they automatically start their set of images and connect back to the remote runner, run the whole lot, and then when the job's finished, it shuts the whole lot down again. And you're basically managing your costs that way, so you don't have the workers sitting there the whole time. So there's a couple of things that we are still working on. The initial image synchronization, so I mentioned that we have the code sync capability. And what that does is that as I'm making a change in editing methods and everything, it'll send those changes down to the worker. But it assumes that when you start the worker, that's in exactly the same state as my development image. And that might not always be the case. So what we'll be able to do is say that as long as my development image and the worker image have a common root, at some point in the past they were the same, the remote runner will be able to say, here's my current status, and the worker image will then just go, okay, I'm going to apply all the appropriate changes, get into the appropriate state, and now I'm ready to take tasks and do whatever it is that the remote runner wants me to do. For the configurable task retry, if I'm running tests, you don't want to send a single test down to the worker because tests can be over in a fraction of a second. The communication then is actually going to take longer than the tests. So what I want to do is group tests up so that each group of tests takes about 10 seconds. But of course, now I have the issue that if I have multiple tests in one task, and one of those tests causes a major problem, it crashes the VM or it puts the image into an inconsistent state, at that point, all of those tests will appear to fail. So what I want to do is say, if there's been a problem with that task, I'm going to then retry the task, but I'm going to break it all out. I'm going to say, run each test individually in this case. I'll live with the communications overhead. But at least that time, I'm going to know which tests are passing and which exact test it is that caused the problem. So that's the best case. I might just do it at a fixed number. I might look at it and say, I want to understand what went wrong, and based on what went wrong, I'll decide whether I'm going to retry the task or not. So next week, hopefully. Some other things that we still need to improve. The security at the moment basically is just on the network. So it just assumes that you're running this in a network that no one's going to break into. And if you get in and can connect and know what to do, the sky's the limit. Performance, object serialization and deserialization is a perennial issue for Smalltalk, something that we would still like to improve. There's usual issue with jobs and tasks. So the job at the moment is responsible for generating the tasks, and so it figures out if I've got to want to do one thing on every worker, it's the one that figures out how many workers there are there and how am I going to break those tasks down. So if I've got different requirements for the tasks and different requirements for the jobs, do I subclass it and have the same issue as streams? I have a read stream, a write stream, a read-write stream, whatever, or do I use some sort of composition? So that's something that we're still documenting. Final one is actually a call for help. If anyone has seen this, we have issues with sockets on Windows where if you have a large number of connections and we have something like the JVM has been loaded for tests, then all of a sudden the sockets just go quiet and data doesn't come in. What it looks like is there's this Windows called wait for multiple objects, and that seems to just lose events. So if anyone here is a Windows expert, knows anything about that, I'd love to hear from you. Okay, So let's do a little demo. I showed before a quick script that went through and created a task, created a job and ran it. So see how we'd prefer to use that in practice. So Andre showed this morning, I've got 4 tests here. I can say I want to run them remotely and it'll go through. Now you can see that 3 of the results have come back straight away because they all ran almost instantaneously. And this last test is taking quite a bit longer and then it's failed. So what I would like to do now is see how it failed. So if I have a look, and something I didn't line up. Where is it? I have a look up here. You see that? Yes. I can inspect the object and have a look at the result. And here's my test that failed. And we can see that's the task, this is the test. And now I can go and actually have a look at the trace. And I can see up the top there that in this case, I was trying to get the date and time, and then they've got this process, PVT, private signal. So from that, I can infer that this was actually terminated externally. Something's come along and said, kill the process for some reason. So if I go back and have a look at my code, you can see here, it's actually designed to fail. It's basically saying, keep on going for 60 seconds. The S-unit test framework has a maximum default time of 10 seconds per task, so it's exceeded the time. If I just go in and change it, it's going to resolve it. So just before we do that, if we have a look at the remote runner, you can see that it's idle. It's had 2 jobs submitted so far, and we've run 5 tasks. If I go and actually save this code, if I can just move that over a little bit. What happened then? Let's try again. Okay, so what I'm going to do is go in and save this code. We're going to see that the job count here is going to increment. And it should happen pretty quickly. So I've jumped from three jobs and 5 tasks to 3 jobs and 8 tasks. That's because I've got 3 workers. So I've made a change to the code. Code syncs realized that, submitted a job to say update all of the workers so that they've got the same code. And we've got 3 workers, so 3 tasks. And hopefully now when we run the tests again, we'll see that this passes and quite a bit more quickly because instead of going for 10 seconds, it's only going to go for 6 seconds. And it's still green, okay. Don't you just love this? What have I done wrong? Try it one more time. Still not there. Okay. Well, it should have come back and been green. I've done something wrong. Okay, the demo gremlins have got me. I'm not going to spend more time on that now. I'll just put that back. How's it going? Is that in line? So I can see it well enough. So, in this case, we had everything running in a single process. The jobs were being submitted and the remote runners sitting in a single process. What you might want to be able to do is if you wanted to share all of that environment, then we might want to say, I'm going to have my development image, but I'm only going to have a single runner running somewhere and everyone can see the same thing. So in that case, you can see, hopefully, there's the green lines are a bit faded, but essentially what we're going to do is change it so that everything gets run in a single process. So if I double click on that, what I'm going to do is go down here. Can I see this? So I have a runner here. No, I don't, because I didn't get myself ready. /GT. Okay, so this is starting up and running in a separate process. It started up 4 workers there. And what I'm going to do now instead is tell it to shut down the current runner, tell it to use the headless one, and then have a look at that. And if we watch here, you can see that this runner has now been stopped. That was the old one. It's not connected anymore, and we've got a new one over here, which is sitting there waiting to be used. It's idle, hasn't had anything run in it yet. So we'll try this one more time and see if it's going to work, because it didn't work for me last time. We'll put that back. And the demo gods have got me again. Andre, which class do I need to add this to? Pharo Foxy, I think it is. Job proxy down here. I'm going to add a quick class here. Hopefully that is enough. We'll try it again. Go in here, save it, and run it. See what happens. Okay, still running. Okay, so that's come back. We've got these 2 have failed as before. This one's failed. We'll try correcting it, and hopefully this time it'll be a bit nicer to me. And normally that turns green, and today it's not going to for me. So I'm going to leave it there. That's basically it. So the whole idea is that we can now take this, we can distribute work across multiple workers, we can do code sync, we can do remote testing, we can run large models, and all of this will give us a better environment in which to work. So, any questions? No? Everyone's stunned into silence. Okay, in that case, thank you very much.